This is SpaceTime, Series 29, Episode 58, for broadcast on the 15th of May 2026. Coming up on SpaceTime, unlocking the mystery of water on the Moon, a new Australian-built Lunar Rover to land on the Moon in 2030, and discovery of an atmosphere on a distant frozen world which shouldn't have one. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
New evidence suggests that ice has been accumulating on the Moon for at least 1.5 billion years. The findings, reported in the journal Nature Astronomy, are also pointing to the best places on the lunar surface to find it. More than half a century after Apollo 17 made the last manned lunar landing, a new space race to the Moon is underway, with last month's successful Artemis 2 mission by the United States, and with both the United States and China now aiming to establish their own permanent bases there. Unlike the Apollo program, during which American astronauts landed at 6 different sites on the lunar surface, 21st century missions are all focused on a single location, the Moon's South Pole. Spaceflight pioneer Robert Goddard proposed over a century ago that water ice deposits might exist at the lunar poles, and indirect evidence collected over the past 20 years has lent support to this hypothesis. In space exploration, water ice is a highly sought-after resource. It can be processed into liquid water for drinking and irrigation, split into hydrogen and oxygen for use as rocket fuel, and even used to study the history of celestial bodies in our solar system. Now, researchers have uncovered new evidence showing that ice has been gradually accumulating at the Moon's poles for at least 1.5 billion years in ancient cold traps on the lunar surface. Unlike Earth, whose tilted axis causes the Sun's position in the sky to change throughout the year, the Moon has almost no tilt, and so the Sun's always positioned approximately above the lunar equator. Now, if you're standing at one of the lunar poles, you'd see the Sun staying close to the horizon as it completes a monthly cycle, rather than rising and setting as it does here on Earth. As a result, sunlight can't reach and warm the deep, permanently shadowed floors of craters at the lunar poles. But this wasn't always the case. In the distant past, the Moon did have a much greater axial tilt, but over the last few billion years, it's been straightening out. In 2023, scientists showed that as the Moon's tilt decreased, more and more craters near the poles became permanently shadowed and cooled dramatically. By calculating when each crater lost its exposure to sunlight, the authors were able to deduce the age of each permanently shadowed region. They set out to examine whether there was a connection between the age of a permanently shadowed region and the proportion of its area covered by ice. Ice reflects more ultraviolet light at certain wavelengths than the Moon's normal rocky surface, and that makes it possible to infer where it's located. And ultraviolet light provides an advantage because it emanates not only from the Sun but also from distant stars, and so it can enter permanently shadowed areas. The authors analysed data collected by NASA's Lunar Reconnaissance Orbiter, which is equipped with a laser altimeter and alignment alpha mapping instrument, which is sensitive to ultraviolet radiation. The spacecraft's been orbiting and mapping the Moon since 2009, and the new data has confirmed that permanently shadowed craters near the Moon's South Pole are promising locations to find water ice. The authors found that while these cold traps have been accumulating water ice for at least the last 1.5 billion years, not all are equally effective. For example, the well-known Shackleton crater, which is very close to the lunar South Pole, has been too warm for much of lunar history to collect ice. However, Haworth crater has acted as an efficient ice trap for billions of years, and has therefore been identified as a prime target for future landed missions. One of the study's authors, Oded Aronson from Israel's Weizmann Institute, says the data shows that the earlier a region became shadowed, the larger the area that was able to accumulate ice. This trend began at least 1.5 billion years ago and has continued even over the past 100 million years. And this suggests that ice has been building up on the Moon from a nearly continuous source or sources rather than through a single catastrophic event such as a large comet or asteroid impact. For ice not only to form on the lunar surface but also to persist for hundreds of millions or even billions of years without evaporating, extremely low temperatures are required, around minus 160 degrees Celsius. And regions that retain such cold temperatures year-round are known as cold traps. While there are many permanently shadowed regions that qualify as cold traps, some do not because their surrounding walls can radiate heat into the crater. To identify the most promising regions for finding lunar ice, the authors used geometric calculations to determine which permanently shadowed regions also function as cold traps and when in the Moon's history they acquired this status. Aronson says the longer a given region has been a cold trap, the more ice it's accumulated. In most cases, a crater became shadowed and turned into a cold trap at the same time, but not always. For example, Shackleton Crater has been shadowed for some 3.5 billion years and was considered a promising site in the search for lunar ice. But Aronson and colleagues discovered it only became a cold trap around 500 million years ago. To identify targets for future missions, the authors searched for the oldest cold traps and found several extensive ones more than 3.3 billion years old located near the lunar South Pole. Now, these findings are especially significant since locating and sampling lunar ice is one of the prime goals of NASA's Artemis missions. NASA's long-term vision includes establishing a permanent lunar base around 2030 to serve as preparation and possibly a transit station for future manned missions to Mars and beyond. Aronson says the gold standard proof for the existence of water ice on the Moon would be a sample. It would allow scientists to compare the chemical composition of water on the Moon with that of Earth, and to assess whether and how manned lunar missions could make use of that resource. Although the origin of lunar water remains unresolved, scientists have built a simple mathematical model to explore various possibilities. Now, according to this model, the amount of ice on the lunar surface is affected by three processes: water supply, evaporation, and what's known as impact gardening, the process in which a disturbance in the lunar soil and rocks redistributes ice and buries it beneath the surface. The observation that relatively little ice is found in younger cold traps, combined with the slow accumulation of ice over hundreds of millions of years, led the authors to conclude that both water supply and water loss on the Moon occur at relatively rapid rates, like a faucet filling a leaking bucket. Now, one proposed source of lunar water is that volatile water from the Moon's interior reaches the surface through volcanic activity. Another possible source is the solar wind, that constant stream of charged particles flowing from the Sun, which includes lots and lots of protons. Now, when these protons hit lunar regolith, they can capture electrons to form hydrogen. And these same impacts also break chemical bonds in some regolith minerals like silicon, releasing oxygen atoms, which can then combine with the hydrogen to form hydroxyls, and these can then further bond to form water. A third option is the ever-popular asteroid and comet impact. But not a single catastrophic event. Instead, it will involve multiple impacts occurring every few million years, depositing lots and lots of water ice. Aronson says finding water beyond Earth in liquid and usable form is one of the most important challenges in astronomy. For example, it's vital for life as we know it. As Earth's natural satellite, the Moon is an excellent laboratory for studying the history of our planet and its water. This report from NASA TV.
Since the 1960s, scientists have suspected that frozen water could survive in permanently shadowed craters at the Moon's poles. Both hydrogen and oxygen could be trapped within the lunar soil. So to find water on the Moon, scientists are looking for indications of hydrogen using the Lunar Reconnaissance Orbiter's LEND neutron detector. By observing the interaction of neutrons with the lunar soil, scientists can interpret how much hydrogen is likely to be present. In order to make a detailed interpretation, however, LEND needs to observe a large number of neutrons. Because LRO is constantly moving, LEND is never over one place long enough to count many neutrons. So, to make a detailed interpretation of neutron flux, scientists add together many measurements from many orbits. With each orbit, LEND's dataset gets larger, and its picture of neutron flux continually improves over time. Places on the south pole of the Moon with a suppressed flux of neutrons because of their interaction with hydrogen. These areas strongly suggest the presence of water frozen within the soil. While previous lunar missions have observed indications of hydrogen at the Moon's south pole, the LEND measurements for the first time pinpoint where hydrogen, and thus water, is likely to exist. By combining years of LEND data, scientists see accumulating evidence that there is water on the Moon. And as LRO continues to return data, our picture of the Moon and its water will continue to get better in the years ahead.
This is SpaceTime. Still to come, an Australian lunar rover to land on the Moon in 2030, and discovery of an atmosphere on a distant frozen world which shouldn't have one. All that and more still to come on SpaceTime. NASA has slated the Australian-developed lunar rover Rover to fly to the Moon in 2030 as part of the Intuitive Machine CT4 mission to the lunar South Pole. CT4 will carry a suite of 6 payloads designed to improve science's understanding of the lunar environment as part of NASA's Commercial Lunar Payload Services initiative. The mission will fly aboard the Intuitive Machine's 500 kg Nova D lander, which is designed to deliver larger payloads to the lunar surface. NASA assigned Rover with key research objectives, including collecting new data about the local surface conditions. The Aussie rover will be equipped with an integrated NASA payload, including an analysis instrument intended to demonstrate technology for scientific and exploration purposes. The Australian Space Agency-backed ELO2 consortium, which built and developed the rover, says the four-wheel mobile laboratory is designed to collect lunar regolith as part of a project to extract oxygen from the soil. Key technologies under development for the mission include extreme environmental robotics using AI and autonomous systems, the testing of new advanced sensors and power systems, and new communications technologies. This is SpaceTime. Still to come, astronomers have discovered a thin atmosphere on a distant world far beyond Neptune where no atmosphere should exist. And later in the science report, claims that both micro and nanoplastics floating in the atmosphere could be contributing to global warming. All that and more still to come on SpaceTime. Astronomers have discovered a thin atmosphere on a distant world far beyond Neptune where no atmosphere should exist. The tiny world, catalogued as Trans-Neptunian Object 612533 2002 XV93, is just 500 kilometres wide, which theoretically is far too small to be able to retain any kind of sustainable atmosphere. The findings, reported in the journal Nature Astronomy, raises questions about when and how the atmosphere on this little world formed. Trans-Neptunian objects, or TNOs, include thousands of small comets, icy debris and frozen worlds which circle the Sun beyond the orbit of Neptune. A thin atmosphere has been observed around another trans-Neptunian object, the dwarf planet Pluto, but that has a diameter of 2,377 kilometres. But studies of other objects in the outer rim of the solar system have yielded negative results. That's because trans-Neptunian objects are so cold and they're usually so small that their surface gravity is simply too weak to retain any atmosphere. However, as astronomers watched 612533 2002 XV93 pass directly in front of, or occult a distant background star, they were surprised to see the star's light gradually fade rather than suddenly wink out. And that indicates the light was being attenuated as it passed through a thin atmosphere. Calculations suggest that this atmosphere would probably only last about 1,000 years unless it's replenished. So that means it must have been created or at least replenished fairly recently. Observations by the James Webb Space Telescope show no signs of any frozen gases on the surface that might sublimate to form an atmosphere. One possibility is that some sort of geological event brought frozen or liquid gases from deep inside the body up to its surface. Another is that a comet crashed into this body, releasing gases which then formed a temporary atmosphere. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that micro and nanoplastics suspended in the air could be contributing to global warming, especially over oceanic garbage patches. The findings, reported in the journal Nature Climate Change, claims the contribution of plastics is around 16.2% of the warming effects of soot, also known as black carbon, an air pollutant that contributes to warming. The authors analysed the behaviour of different plastic particles and combined their data with computer simulations that capture how particles travel in the atmosphere, finding that black and coloured particles strongly absorb sunlight compared to white particles. Although this warming effect is small at the global level, it can exceed that of black carbon by up to a factor of 4.7, especially over ocean regions where high concentrations of plastic such as the North Pacific garbage patch are located. Archaeologists have found evidence of people repeatedly climbing up to a cave some 2,235 metres above sea level in Europe's Pyrenees Mountains thousands of years ago to mine and process copper. A report in the journal Frontiers in Environmental Archaeology claims the prehistoric cave was found to be full of hearths that contained fragments of green rocks called malachite, which could represent early copper mining. The authors say visits to the cave started around 5,500 years ago and continued for over 2,000 years. Archaeologists also discovered a child's finger bone and a baby tooth, which might suggest the cave was also a burial site. They say the discovery overturns past belief that human ancestors only ever passed through high-altitude mountain areas. A new study shows that astronauts have to take extra time to remember how to grip and move objects when they transition to and from space. The findings, reported in the journal J Neurosci, found that gravity has a lasting imprint on the brains of people who have been living in microgravity, and it affects how they attempt to anticipate gravity's pull. Additionally, the authors say astronauts who have spent months off the planet also tend to forget that objects are affected by gravity once they return to Earth. They actually forget that when they let go of something, it'll fall down. An article in the magazine Psychology Today, which is not peer-reviewed, has slammed scientists for dismissing claims of paranormal abilities and experiences, asking, what are they scared of? The article claims reactions by scientists to papers on subjects like remote viewing went far beyond scientific critique and seemed to reflect a deeper discomfort with certain topics of investigation. The author claims that over the years, they've come across responses that exceeded normal scientific disagreement. Some were subtle, others remarkably direct. One reviewer evaluating a manuscript on remote viewing simply wrote, "This is pseudoscience. Remote viewing is indistinguishable from random guessing." Of course, you and I know he's correct. Another reviewer of the same manuscript went on to say that it was an abuse of the reviewer's time. A paper by the author claiming how to provide evidence of life after death was dismissed with the comment, "How did you find 20,000 words to write about something that doesn't exist?" The authors say addressing the subject matter seriously challenges deeply rooted assumptions about the relationship between mind and brain. This would raise complex questions about the nature of consciousness and the limits of current scientific models. The skeptic's Tim Mendham points out the writer's problem isn't the subject matter, it's the fact that they're relying on hearsay and anecdotal evidence rather than undertaking a rigorous scientific testing of their hypothesis.
An article that was published in Psychology Today, which is a popular consumer publication, it's not a learned journal by any means, it's not sort of peer-reviewed, does tend to have a bit of the sort of light on the evidence, more on anecdote type articles, and certainly the ones I've been looking at recently. One of them is saying that the scientific community often refuses to even look at what they call the PSI question, which is the paranormal psychic sort of things. And they suggest that a skeptic should ask, what does the evidence suggest? Could there be another explanation? How can we test this more rigorously? The person here who's writing it talks about the need for skepticism in science, that science is based around skepticism and critical thinking and assessing other people's claims. They say that in the article, the author says that we design experiments. The emphasis, I think, is on we. They're obviously pitching themselves as scientists, and so they understand. The trouble with this, when you talk about scientific evidence and critical thinking and looking at the sources, this article is anecdotal, pure and simple. It basically says that when you put forward a theory or a paper or something like that about that is sympathetic to or we're a believer in psi phenomena, the reaction by the scientists is instantaneous, don't go away, it's rubbish. And I can imagine actually that does happen, but the explanation this person gives is that it's either a religious-based thing, it upsets the way I think about the world, etc. It's an emotional response, they're saying.
Yeah, but that's not correct. It's a scientific response.
I know. They say they've got a few examples of this thing of people being knocked back. They don't have any sources really for this. They just say these things happen. They don't say who, etc. Apparently that would happen to the author as well. And they instantly think it's a censorship issue, that we're being censored in our ideas, and they therefore confuse censorship with rejection, right? Just because your paper is being rejected as being a bit silly doesn't mean there's a censorship thing to stop you. Unless if this person said it happens all the time, well, maybe you're always submitting censorship things.
That's a case of shooting the messenger rather than the message.
Totally. And this person doesn't doubt the message. In fact, they conclude their article with the central issue may not simply be whether psi exists. Perhaps the deeper question is, what exactly are we so afraid of discovering? No, the deeper issue is, does psi exist? And if you're putting forward anecdotal evidence and pretty wishy-washy scientific papers, it's not surprising that people who are assessing papers all the time, coming across weird claims, would say, I've done this before. Certainly skeptics face this all the time. I've seen this before. I've seen your claim of psychic powers or Bigfoot or whatever 100 times before. I somehow doubt we're going to get the answer, the positive answer here, so try somewhere else. If that's what this person is complaining about, they're actually blaming the person who's reacting to it. Now, this is a one-on-one reaction they're talking about. I send a paper, one scientist rejects it, whereas they don't understand the idea of one-on-many reaction. If a lot of scientists have seen this sort of thing and they all go, oh, here we go again, it obviously says you've got to have better evidence.
We see the same thing with global warming, where you'll find one scientist who's sceptical of global warming, not mentioning any Australian geologists by name. Hello, Ian, if you're listening. And you totally ignore the fact there are 10,000 other scientists who say global warming is real. Well,
this is always the case, too, that skeptics come across, that they claim, and especially of sort of pseudo-medicine and things like that, claim scientists are against it. Scientists don't know what we're talking about. Here is my claim, and here is a scientist who endorses it. And you think, okay, you found the one. There's always a scientist to endorse something. And therefore, criticise, wipe off all scientific response and say, but here's a scientist who supports me, therefore they have the imprimatur of being a scientist, while all the other scientists are obviously rubbish. It just doesn't follow. And the thing is, as you say, I would say, look at what you're presenting rather than the way people are reacting to it. Perhaps they are reacting to it for justifiable reasons, but it's not very good.
That's Tim Mendham, and this is Space Time. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.